In large enterprise deployments, you'll probably have different programs serving each of the networking services that we covered in this module. In smaller setups, you may be better off having a centralized solution that handles all services. Let's look at Dns Mask, a program that provides DNS, DHCP, TFTP, and PXE services in a simple package. This will let us do some hands-on configuration of these services, even if it's not as complex as other networking solutions. Let's start by installing Dns Mask in this machine. So I'm going to type in sudo apt install dns mask. Once we've installed Dns Mask, it's immediately enabled with the most basic functionality. It provides a cache for DNS queries. This means that you can make DNS requests to it, and it'll remember the answers so your machine doesn't need to ask an external DNS server each time you make the query. In order to check this functionality, we'll use the dig command, which lets us query DNS servers and see their answers. So let's ask our DNS server running in localhost for the address of www.example.com. We do this by running dig www.example.com at localhost. The part after the @ sign indicates which DNS server we want to use. Here, we have the reply from our query. Our DNS server is telling us the IP address for the domain example.com. How do we know that this query was actually answered by the service the machine is running? We can run the service in debug mode so we get more information about what's going on behind the scenes. This isn't how you would normally run the service, but it's useful for understanding what's happening. So let's stop the Dns Mask service that's running, then start it in debug mode. So now I'm going to type in sudo service Dns Mask stop. Then type in sudo Dns Mask with a D flag and then pass the Q flag. By passing D and Q, we're telling Dns Mask that we want to run it in debug mode and that we want it to log the queries that we execute. When it starts, it prints in the compilation options that are enabled and the configuration files that are used. Now, we can query it again with our friendly dig command. If we run the command again, we'll get the same answer and we'll see the debug output in the Dns Mask console. So in my second console now, I'm going to go ahead and type in dig www.example.com at localhost. This is showing us that our Dns Mask service received the query, forwarded it to the configured DNS server, and then replied to the original machine. If we query for the same hostname again, we'll see that instead of asking the other DNS server, Dns Mask replies with the cached query. So now my second console, I'm going to type in, again, dig www.example.com at localhost. So if I hit enter, for now, Dns Mask is operating as a simple caching DNS server, but we can make it do more than that. For example, we can give it a list of hostnames and IPs and have this service give authoritative answers for them. You might remember that when trying to resolve a host name to an IP, there can be servers that store the information about the mappings, which can then provide the authoritative answers, while other servers will only be able to forward and delegate the queries to the server that had the information. These files had the same format as the etc host file. I've created this file that lists the internal host that I want to be able to resolve. So I'm going to type in cat myhosts. As you see, it's a very simple format. You just have to list which IP is associated with each host. We use the H parameter to tell us Dns Mask that we want to include this list in the information being served. So I'm going to cancel this, clear, and now I'm going to type in sudo Dns Mask dq h my host. Now that we have our list of hosts loaded, let's query it with dig. So now, on my second console, I'm going to type in dig oxygen.local at local hosts. As DNS Mask is authoritative about this host, there's nobody to forward the question to. It also lists which file it's using to get the information. Neat, right? Finally, let's see what the output looks like when we ask it for information that it doesn't have. So I'm going to type in dig hydrogen dot local at localhost. We see that it replied that the authoritative servers are the root servers, but that it couldn't find any results. And what did the running DNS mask say? Since the requested name isn't in the list of hosts known to our DNS server, it forwarded the query to the configured DNS server. The reply for that was NX domain, which means non-existent domain. While DNS Mask is as simple as it gets, you've now seen what a DNS server looks like in action. Cool, right? We've seen how to use DNS Mask to serve DNS queries, but as we mentioned before, DNS Mask can also be used for other networking services. Let's look at how it can be used as a DHCP server. A DHCP server is usually set up on a machine or a device that has a static IP address configured to the network interface which is being used to serve the DHCP queries. That interface is then connected to the physical network that you want to configure through DHCP, which can have any number of machines on it. In real life, the DHCP server and the DHCP client usually run on two separate machines. But for this example, we'll be doing a simulation on one machine so that you can experiment with a similar setup in the upcoming quick lab exercises. In this machine, we have an interface called ETH_SRV that's configured to be the DHCP server's interface. So now I'm going to type in IP address show ETH_SRV. This command shows us that this interface has the 192.168.1.1 IP address. The /24 part indicates that this IP is in a network that goes from 192.168.1.0 to 192.168.1.255. If this isn't clear, you may want to review the lessons on IP addressing in the networking course. The interface also has an IPv6 address configured, but we won't go into IPv6 for this example. We also have an interface called ETH_CLI, which is the interface that we'll use to simulate a client requesting an address using DHCP. This interface doesn't have an IP configured yet, so I'm going to type in IP address show ETH_CLI. We can see that this interface doesn't have an IPv4 address configured. We'll change this by using our DHCP server. To do this, we need to provide additional configuration to DNS Mask. There are lots of things we can configure. We're going to use a very basic set of options. Let's look at the configuration file. So I'm going to type in cat dhcp config. The interface option tells DNS Mask that it should listen for DHCP queries on the ETH_SRV interface. The bind interfaces option tells it not to listen on any other interfaces for any kind of queries. This allows us to have more than one DNS Mask server running at the same time, each on its own interface. The domain option tells the clients the network's domain name and will be used for querying host names. Then we have two different DHCP options, which are additional information that will be transmitted to DHCP clients when the IP is assigned. In this case, we're telling clients what to configure as a default gateway and which DNS service should be used. There are a lot more options that we can set, but these two are the most common ones. Finally, we configure the DHCP range. This is the range of IP addresses that the DHCP server can hand out. Depending on your specific setup, you may want to reserve some of the addresses in your network for machines that need to have a static address. If you don't plan to do that, you can make the range larger, but make sure you don't include the address of the DHCP server itself. The last value in the DHCP range line is the length of the lease time for the IP address. In this case, it's 12 hours, which means that once an address is assigned to a machine, it will be reserved for that machine for those 12 hours. If the lease expires without the client renewing it, the address can be assigned to a different machine. Alright, we've gone through the configuration file. Let's tell Dns Mask to start listening for queries using this config. So now I'm going to type in sudo Dns Mask dqc dhcp config and then hit enter. We can see in the output that Dns Mask is listening for DHCP queries on the ETH_SRV interface with the options that we set in our configuration file. Now, let's run a DHCP client on a second terminal. So I want to open up the second terminal. Now on my second terminal, I'm going to type in sudo dhc client I eth CLI and then v for verbose. We're using DHC client, which is very common DHCP client on Linux. We're telling it to run on the eth_CLI interface, and we're using the -v flag to see the full output of what's happening. Back in the networking course, we explained the whole process of DHCP client getting a DHCP lease, and here we see the packets being exchanged and how our client got the IP address 192.168.1.80. We also see that the DHCP client expects to renew the address before it expires. Let's see how our interface looks now. So now I'm going to type in IP address show eth_CLI. Our eth_CLI interface has successfully acquired an IP address. Now, let's look at what Dns Mask printed when the request was made. We see the same packet exchange that we saw from the client, but Dns Mask also shows that it now knows the host name of the machine with the address 192.168.1.80 because Dns Mask also has DNS capabilities. This means it will also provide this as an authoritative answer for local queries. So now I'm going to type in dig at localhost instance 1. And with that, we've seen how Dns Mask can act not only as a DNS server, but also as a DHCP server. This setup was a simulation to show you what you can do with Dns Mask. As mentioned earlier, in real life, you would have this on separate machines, physical or virtual. If you want to test a setup like this, you would normally do that on a separate network from the production network. Remember, never test in production. We covered a lot of information in this module. You've learned about the overall services needed in IT infrastructure. On top of that, you learned about the physical infrastructure services like remote access and virtualization that help your organization run more efficiently. You even learned about essential network services like DNS and DHCP, along with the overall picture of what's needed to set up DNS for an organization and why you'd want to do that. And we've seen lots of these services in action. Now, we're going to let you practice with some quick lab exercises and test you on what you've learned. And don't forget, you can always go back and review the material again if you want before you take the quiz. In the next module, we're going to cover 2 of the other IT infrastructure services, software and platform services. I'll see you there.